Okie doke. Onwards. Uncertainty and imperfect information. So we're going to have a look at a couple of problems with uncertainty going on. And of course, first we'll start with 4.1. Assume a competitive firm emitting pollution. The marginal benefit from emissions abatement by the firm is given by the following function. MB is B1 plus B2A. The B's are positive. Marginal costs are C times A plus eta. And eta is less than B1. Okay. Note that total benefits and total costs are as follows. So if we do the integrals, total benefits are B1A plus B2 over 2A squared, I think, and total costs should be eta A plus C over 2 A squared. That's a capital C, that's a small c. Okay. And we're asked about first best. Abatement. So, how do we find that? I'm just going to take stock here. Okay, yeah, so first best abatement, we've got costs and benefits. So, I mean, we could set up the minimization or the maximization problem and take first order conditions, but we're basically going to get back to here, but with marginal benefits equal to marginal costs, aren't we? So let's just write down the answer. B1 plus B2A equals CA plus eta. So remember, we could have set up a net benefit maximization problem where net benefits are this minus this and taken first order condition in A, and we get this, of course. Okie doke. And of course it's A that we're interested in. So if we collect terms and we know something, yeah. So we end up with A being B1 minus eta over C minus B2. And the question is whether this makes sense. We're told that eta is less than B1, so this is positive, but if B2 is greater than C, then this would be, A would be negative. Negative abatement doesn't make sense. So if B2 is less than C, this is fine, but if B2 is greater or equal to, no. If B2 is less than C, this is fine. Otherwise, this doesn't make sense, and we need to look at the corner solutions. And I'm just going to have a think about the corner solutions. Okay, 20 seconds later, the corner solutions. To get a grip on those, why don't we plot marginal benefits or marginal costs against abatement. Okay. And the thing is, they're both sloping upwards, aren't they? We're told that eta is less than B1. So the benefits are like starting here at B1, and the costs are starting here at eta. Yeah, when A is 0. But then the question is, does it look like this? So let me see, this is costs, and this is benefits. So does this make sense? So that's when we get the internal solution. Does this make sense? Yes. So up to this level of abatement, benefits exceed costs, so this is correct. We should abate up to here. But what if these two lines meet on the wrong side? Then what have we got? We've got that benefits always exceed costs. So I guess you're going to abate all your emissions, aren't you? You're going to set abatement to a corner with no emissions. Let me just check that. Okay. I think we were on part B, right? And we've introduced the uncertainty. So now we're saying that eta is known by the firm, but not by the regulator. But its expected value is 0. What is the first best abatement level contingent on the value of eta? Okay. Yeah, I misunderstood this question for a minute there. But if given eta, it's just the answer we got before, right? It's that A is B1 minus eta over C minus B2. If we're assuming that there is an internal solution. Yeah. So if we take away the uncertainty and like ex post, once we know what eta is, this would be the optimal abatement. For part C, what's the level of A that maximizes the ex ante expected social welfare? In other words, assume that A must be chosen before E is realized. What value of A should be chosen? Okay, 20 seconds later. We need to choose the value of A that maximizes the expected value of benefits minus costs. So what's our problem? It's to maximize, through the choice of A, the expected value of B of A minus C of A, which is the expected value of this lot, yeah. B1A plus B2 over 2A squared plus eta A plus C over 2A squared, which is well, the expected value of this plus the expected value of this plus this plus this. Okay, but the expected value of eta is 0, so it's just, and the others are all known, so we can take away the expectations operator and say that it's B1A plus C sorry, yeah, minus signs here. It's B1A minus C minus minus B2 minus C minus B2 A squared over 2. Okay, so we want to maximize that. So we take the first order condition in A and we get that B1 equals C minus B2 A is B1 over C minus B2. And I'm going to pause again and take stock. Okay, where were we? Part D. What's the level of the emissions tax TOR that maximizes the ex-ante expected social welfare? So again, it's a typical case. We've got a regulator thinking of imposing the tax. What does the regulator need to think about? She needs to think about how is the firm going to react to the tax. So the regulator needs to put herself into the firm's position. The firm, what are the firm's costs? They are eta A plus C over 2 A squared plus TOR E bar minus A, I would say. I think that makes sense. Let me see. So then the first order condition will give that eta plus 2 C times A. Remember, eta is known by the firm. Minus TOR equals 0, so equals TOR. A equals TOR minus eta over C. Okay. So if the regulator chooses tax TOR, the firm will abate to this level. But the regulator doesn't know what eta is. But let's put this in the margin here. A is TOR minus eta over C. Now I'm going to do some rough. So the next step, the regulator now knows how firms are going to react, and now the regulator wants to maximize net benefits, or expected net benefits, which is the expectation of benefits minus costs, which is B1A plus B2 over 2 A squared plus eta A plus C over 2 A squared. And then we can stick in TOR minus eta over C everywhere. And we get E of B1 plus eta TOR minus eta over C. Well, I've done this again. Should have minus signs here. I need to be more careful, don't I? B1 minus eta plus B2 minus C over 2 TOR minus eta over C squared okay. So now then, what's the expectation of this? if we multiply all this out, we're going to get terms without any etas in. We're going to get terms with etas in, and we're going to get terms with eta squared. But all the terms with an eta in or with an eta squared in, the expectation of those is 0. All the other terms, the expectation is that we actually all the other terms, we know exactly what they're going to be. So we can write that the expectation of n is simply, we can treat these etas as 0 from this point on, and we have b1 tau over c plus b2 minus c over 2 tau over c squared. You could easily verify that if you want. If you're not confident about that, you could do all these multiplying out and then set the eta terms to 0. You'd end up with this. And we want to maximize the expected net benefits through choice of tau. And that will be when the first order, for the first order condition, so we're going to get b1 over c equals c minus b2 over 2. I've taken it across and switched the sign. I should have had a minus that the whole time, times 2 times tau over c. Oh, no. Tau squared over c squared. Tau squared, 2, blah, 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 tau, but we've still got c squared there. So that goes out with that. And we end up with tau equals b1c over c minus b2. Oh, yes. And that, why am I saying yes? Because it fits my crib sheet. And we can stick that back into here, I guess. And we have tau over c, so that, and minus eta over c. So then we'll get abatement is b1 over c minus b2 minus eta over c. And that is that. For now I'm going to take stock again. Okie doke. So part E is extremely straightforward. It's basically assume the level of A maximizing ex ante expected social welfare is actually used. Okay. So you're just telling firms that, look, you have to abate a certain amount, whatever it was we worked out. I guess it was this. With eta being 0, I suppose, the expected. And of course, if eta turns out to be 0, that will be first best, and we'll all be fine. But if it turns out that abatement costs are unexpectedly low, that either it's negative, then we would have liked firms to abate more, and if eta is unexpectedly high, above 0, then we would have, in first best, we would have asked firms to abate less in the Planner's solution. So that is very straightforward. Okay, and finally we're supposed to tie up the sack, as the Swedes say, and compare these different options. Abatement level under taxation with first best. So first best is here, is A star, if you like, is B1 over C minus B2 minus eta over C minus B2. The sort of best guess, if you're just going to impose abatement, is like A best guess or something is just B1 over C minus B2. But if you instead have the best guess of the tax, you end up with this, which is closer to first best than, so that's the abatement you get with the tax, which is closer to first best than if you just impose abatement. So by allowing the firm to adapt to the tax rather than simply imposing your best guess, you let the firm save costs. So I guess that's actually quite an important result to do with the advantages of imposing taxes or tradable permits compared to just imposing abatement quantities on firms when you don't actually know their costs. And that is the end of that question.